Hey, welcome to Unit 2, Section 3. Let's start off with an argument I hear a lot in my classroom sometimes. Here we go.
You're out of your mind. There is no way that LeBron will ever beat Jordan. Nobody will ever beat Jordan, okay?
Okay, LeBron's a better rebounder and passer.
Will you let me finish? Can you let me finish? Call me when LeBron has 6 championships.
Is that your only argument?
It's the only argument I need, Sean!
So you might be wondering, what would this look like if we wrote it up in a proof? I know you're wondering that. So here we go. We have LeBron James and Michael Jordan. We're going to write their argument up in a proof. Given, Jordan has won 6 championships. By the way, he lost 0. And he took 2 years off in the middle. That's 6 straight when he's playing. LeBron has won 2 championships, but he's also lost 2. Sad face. All right, so we're going to prove that Jordan's better than LeBron. So the first thing we always do in a proof, we write down the given. So our given is that Jordan has won 6, LeBron has won 2. Oh, that says lost 1. Oh, my mistake here. Lost 2. Sorry, my bad. All right, the reason we always give for the first statement, it's always our given, so the reason is given. All right, next statement. Jordan is better than LeBron. And that's the definition of better. It's like winning games means you're better. Winning championships means you're better. Not losing them. And we have a lot of other reasons too why he's better. You know, you could use the doesn't cry in public clause or the doesn't actually have to go find a championship team. He makes them. But anyways, we're going to move on. We have all these properties for proofs. You have to put them all in your brain. I'm not going to give them to you. They're going to be on the test. You have to know them. We're going to do 3 proofs today, and we're going to get started here. And when we're done with our 3 proofs, then you have a bunch of practice. We're going to start with an algebraic proof. Okay, so we're going to write things out. I'm going to go as quickly as I can here. If you remember what we do, we always start with the first statement is always what they give to us, and our reason why is given. Now, what we're going to have to do is solve this equation until we get to x equals -1. And to do that, you might do it a couple different ways here. I mean, you might want to distribute first. Another person might want to add 100 to both sides first. And so your proofs could look different. I'm going to emphasize that. Your proofs could look different from each other. Your reasons have to match up with your statements, though. This is why it's pain in the butt for teachers, because you got to go through and it's just not one correct answer. We have to look at each line and make sure that what you're writing is valid. All right, and we're going to do that. So make sure that you're really meticulous on what you're writing here. Now, I'm not going to write the plus 2 on each side of the equation. What I'm going to do is just write the resulting equation. And I'm going to look at this equation right here and then figure out, well, what's the first thing I would do to solve it? I mean, what would you do if you're going to solve this equation? Well, if you were me, I would probably distribute the negative. And so that would give me an equation that looks like this. Okay, you get a -4x and a +2. And the reason why I would do that or get that equation is because I used the distributive property. All right, that's no secret. Then what would happen? Well, here's where we could get, a couple different options. I would combine like terms. I would combine the -100 with the +2, the +2, and I'd get -98. Someone else might do +100 +100 and then use the additive property. That's okay. That's not what I'm going to do, though. I'm going to add those like terms together and get -98 minus 4x equals -94. Now, I combine like terms, so that's my reason. Okay, if you did it a different way, then you have to use your reason. Okay, next I would add 98 to both sides, and that would give me a -4x equal to 4. And when you add to both sides, that's using the addition property. Now I'm going to pause a little bit because some students always get confused. The addition property, up here I added -100 and a +2. That's not the addition property, even though I added those two together. The addition property says that you can add to both sides of the equation. And that's what I did on step 4 to get step 4. It's not what I do to go from step 2 to 3. You don't add to both sides of the equation. You actually just combine like terms. So that's the difference between the two. Wanted to point that out because students often get confused with that. All right, last step. I divide by -4. I think everybody's okay with that. That gives us a -1, and that's the division property because I divide both sides of the equation by -4. And if you look, the proof up here is exactly the same as the very last statement. And so we're all done. If I was that little nerdy guy, I'd write QED at the end of it, but you don't have to do that. We're done. I mean, that's it. And remember, the first statement will always be your given, and the last statement should be what you need to prove. And that's what we have right here. All right, so there's an algebraic proof. I go through it at my own speed, and I do my own thing to it, and that's why they could look a little different. The next proof, in example 2, is a geometric proof. Okay, this is the type of proof where you cue the headache to come to your brain, because that's what's going to happen. You have to look at the picture and figure out how to get from A to B. And as we all know, A is the given and B is the proof. All right, so we're going to start off by just taking a look at the picture here. We have 1, 2, 3, 4 angles. We have lines L and M. And so just, off the top of my head, what do I know? Well, I know that we have supplementary angles, okay? 1 and 2 is a linear pair, 1 and 4 is a linear pair, 3 and 4, so on and so forth. We also have vertical angles, okay, and they should be congruent to each other. They're giving us that angle 1 is congruent to angle 4. So we're going to start with that as our first statement. And as always, the reason is given. Okay, they gave it to us. So let's go through. Let's use our vertical angles actually. All right, if you know something, here's a good thing. If you write something down and it's true, but you don't need it, you're not wrong. I mean, you can write that down, but we're not going to be wrong here. We're going to need that. 1 is congruent to 3 vertical angles. All right, so what about the other one they gave us? Well, they gave us angle 4 in the given. Okay, I always look in my given. What did they give us? Angle 1 and angle 4. So what do we know about 1? Well, it's vertical to 3. What do we know about 4? It's vertical with 2, so they're congruent to each other. So I'm going to write that down. 2 is congruent to 4. The reason why is vertical angles. All right, now what I'm going to do is play a little game of, look at all these. We got all these angles in here, and we have 1 repeating, and we have 4 repeating. And normally that's a sign we're going to substitute. So if we look at steps 1 and 2, I'm going to take out the 1, and I'm going to put in the 3. That's what this says. Okay, here's your 3. Well, let's do it the other way. Here's 1. Here's another 1 right there. We're going to take out the 1 and we're going to put that 3 in there. We're going to substitute. Okay, so what's that going to look like when we're all done? Well, 3 is congruent to 4. Take that 1 out, put a 3 in. And the reason why, substitution property. Works just like our equations. Now what? Well, now, see this 4? 2 is congruent to 4. Well, 4 is right here. So I'm going to take the 4 out. I'm going to put a 2 in. That's going to give us angle 3 is congruent to angle 2. But that's not the same as 2 is congruent to 3. It's close, and we're almost there, but that's not the same. So what you're going to have to do, you're going to have to write a number 6 underneath the table. Mr. Kelly. And you're going to have to, what's the next step? Well, if 3 is congruent to 2, then we know that 2 is congruent to 3. Which property that is? The symmetric property. All right, so that's how you do the geometric proof here. That's one method. But remember, I told you at the beginning there are different ways to do this. I'm going to back us up a little bit. Let's back up here. Took away everything from step 4 down. I'm going to back it up. Now, you don't have to write this down, but I want to show you something. If you're clever, and we're all clever in some way, we have to look here. You want to prove that 2 is congruent to 3. Well, that means I want the 2 first. So when you go to do your substitution, look, 2 is congruent to 4, 1 is congruent to 4. Why don't you substitute right here? All right, instead of having a 4, substitute in a 1. Well, what difference is that going to make? Well, that means that the 2's in front. We're going to use the substitution property. And now the only thing I have is a 1 right there instead of a 3. But look, step 2, 1 is congruent to 3. I can take that 3 and put it in there. And look, I saved us a step. Now, as I said, Mr. Kelly's going to give you the certain number of rows that are supposed to work. This is the way that I conceived of this proof. That's the way I would do it. The other way that you wrote down is okay too. And I want to emphasize that. There are a couple ways to do these. All right, so I'm going to tell you what I'll do. I'm going to talk you through this proof. And then I want you to write it up all formal with all your statements and reasons and everything lining up, okay? We'll pause the video when I'm done here. I'm going to explain it. If you think you can do it without me explaining it, then pause the video now. But here's how I would do it. They give you that 2 is congruent to 5. Those are called corresponding angles. Corresponding angles are congruent. We know that. But that's given. They want us to prove that 4 is congruent to 8. So here's how I would do it. I would say 2 is vertical with 4. So 2 and 4 are congruent, and 5 is congruent to 8. And then using substitution, I would get 4 congruent to 8. So if you haven't already, pause the video, write it out, and we will continue. Okay, so we're back. As I said always, the first statement is your given. Your reason is given. And I would do my vertical angles. 2 is congruent to 4, and then 5 is congruent to 8. Vertical angles are always congruent. So now using substitution, if you do this smartly, is that a word, smartly? I think it is. 4 is congruent to 8 is what we're looking for. So I want a 4 in the front. So here's what I'm going to do. I'm going to substitute this 4 in up here at this 2. Here's 2 right here. There's another 2 right there. I can substitute the 4 in for that 2 and get 4 congruent to 5. Okay, so let's do that. I'm going to write that out. And the reason why is the substitution property. We substituted. And now we're almost done. We need to get that 5 and do an 8. But look above. 5 is congruent to 8. So I take out the 5, put in the 8, and we're left with 4 is congruent to 8. All right, so that again is substitution property. Now, I said you would do 3 proofs, and I lied to you. Sorry, we actually have 4. Hopefully that one makes lots of sense. Here's another one. It's well, it looks kind of weird. I mean, it looks like a butterfly or something. I like it, but it's butterfly. Okay, but we're looking at 1 and 2 are supplementary. So angle 2 is this huge angle up here. That is almost 180 degrees. If it had just a little bit more, it would be a straight line. And here's that little bit more right there, angle 1. And then it says 2 and 3 are supplementary. And they want us to prove that 1 is the same or is congruent to angle 3. All right, so if you think you can do it, pause the video, go ahead. If not, then follow along. Here we go. Alrighty, mates, this one's a wee bit tricky, so let's get started here. First, the given statements. We're going to write those down, and I'm going to use 2 whole rows for that. Hey, how about that? We have that 1 and 2 are supplementary, and 2 and 3 are supplementary. Your reason why is given, of course. And then what am I going to do? Think about it. Well, they give you the word supplementary. They give you a couple angles, too. No vertical angles here, can't use that. No linear pairs or anything, can't use that. But they do tell us supplementary. So what does supplementary mean? I mean, if you don't know what to do, then, well, what does this mean, supplementary? Supplementary means that their measures add up to 180. Now, I'm being very specific here. I'm not putting angle 1 plus angle 2 equals 180. You can't add angles. You can only add the measures of the angles. The measures are actual numbers. Okay, the angles are angles. They're not numbers. You can't add them. But you can add their measurements, so I'm going to switch and go from, we're going to say the measurement of angle 1 plus the measurement of angle 2 has to equal 180. All right, the reason why? Definition of supplementary. That's what supplementary means. Okay, we looked at the word and we figured out that it equals 180 degrees. So once we know that for one set, we can write that again for the second set. So angle 2 plus angle 3 must equal 180. All right, now I'm going to do a little bit of trickery. We have 180 degrees twice. This equals 180. This equals 180. Well, I'm going to take the 180 out. Here it is again. And I'm going to put what it's equal to. Oh, I'm going to put that up here. All right, so what's that going to give us? And why do we do that? Well, we did that. We're going to substitute. 1 plus 2 is going to equal, instead of 180, 2 plus 3. And that is the substitution property. Now, if you look at this, we need to get to 1 is congruent to 3. Look, we're almost there. 1 plus 2 equals 2 plus 3. 1 and 3 are there. The only thing extra, we have a couple of 2's on each side. We don't want that, right? How can we get rid of it? Let's subtract it. So we subtract the measure of angle 2 from each side. What do we get? The measure of angle 1 equals the measure of angle 3. We are almost done. It looks pretty close. And honestly, your teacher might take that and you might be done for the day. But I'm going to say you're not really done yet because you're talking about the measures here. You're not talking about being congruent. You're talking about being equal, so on and so forth. So we need one more step. So step 7, and what are you going to write? Well, you're going to write what they want you to prove. Angle 1 is congruent to angle 3. So what's our reason? This is what students have a problem. Like, what's the reason for that? You didn't tell us, Mr. Kelly, the reason for that. Well, what is the reason? Why can we write these are congruent if we know their measures are equal? Well, that's what congruent means. That's what congruent means. So we write the definition of congruent. Hey, that's it. We got lots of different... It's impossible, I'm going to tell you right now, it's impossible for me to show you every single proof and then say, well, study the proofs. I can't do that. You have to be able to think through it, and that's why you actually learn this in geometry, to get your critical thinking skills up. So this is Mr. Kelly. That's it for the unit. You're going to have a small test. It's going to be a one-pager. Make sure you do the review. You should be all set, but none of that until you pass the third mastery check. So as always, this is Mr. Kelly Baumholder. Remember, it's nice to be important. It's more important to be nice. See you.
who has 6 rings because of Michael Jordan.
Yeah.
To utter such a thing, it is blasphemous. He should be banned from the city for at least a year.
And the thing is, Jordan defied conventional wisdom. That's why we believe he's the greatest of all time. Nobody ever dominated the game like Jordan.
LeBron is going to be one of the top players who ever played a game. Like Tiger, Jeffrey, Jordan is the best basketball player who played the game.
I think it's a plausibility. I think it's something that maybe 2 years from now, maybe one more MVP from now, maybe 1 or 2 championships from now for LeBron.
How about 6 rings
I think all
from now?
All of a sudden it's realistic.